Continue with proving triangles congruent. This one, or excuse me, proving triangles similar. This time by side, 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 and side angle side. So a few statements. First, if the corresponding side lengths of two triangles are proportional, then the two triangles are similar. What that really means, let's say I have two triangles A, B, and C, and then D, E, and F. Okay? And if I know that AB is to DE, so corresponding sides, or excuse me, AB to DE is to BC over EF to AC over DF. Corresponding sides are proportional. In other words, if you divide them, if you find the ratio of their side lengths, and you get the same number, we call that our scale factor, or similarity ratio, then we know that the triangles, in this case ABC, would be similar to DE and F. And the order in which you put the letters matter here, right? AB, AB, DE, DE. First position, second position, first position, second position. BC, second, third, EF, second, third. AC, first, last, DF, first, last. So it's a way to kind of read your statements there. All right? So, determine if the triangles are similar. Let's explain. If similar, write a similarity statement. All right, so the first thing you'd have to do is you have to look at the triangles. I'm looking at the longest side, so 84 would have to be to 14 when we compare those. As, let's see, the shortest side, 48 to 8. And then the remaining side, 72 to 12, or sides. So if all those reduce to the same numbers, then we're good to go. So 84/14 reduces to 6 over 1. 48/8 reduces to 6 over 1. And 72/12 also reduces to 6 over 1. Or if you divide them all, you get 6. Therefore, by side angle side, oops, not side angle side, excuse me, side side side, triangle AB, BC is similar to triangle HGF. Okay, so A to B, H to G. Okay, so make sure you have them in the correct order there. All right, you've shown it by your similarity ratio. Okay, so we do the same thing on these two triangles. So let's look at the longest side, so 52 to 28. And then 40 to 16. And 40 to 16. Okay, obviously 40 to 16 to 40 to 16, that part's proportional. All right. If we reduce 52 28, that becomes 13 over 7 if we take a 4 out of those. Take a 4 out of these, we get 10 and 4. Okay, which also reduces 5/2. Okay, so definitely not proportional. This would obviously reduce to 5/2. But these two are not proportional, therefore not similar. Sides are not proportional. There's a good explanation there. And you have the math to back that up. All right. Very good. Well, let's go ahead and take a look at some others here using the side-side-side similarity theorem. If we want to find a value that makes triangles similar, so in this case, find the value of x that makes the triangle similar, we could do that. We could set up our similarity ratio. We know big side or longest side to longest side would have to equal, in this case, looks like the medium side, so 11x plus 11 over 30. Okay? Or you could have said another one. You could have said 77, shortest side, over shortest side is equal to medium side over medium side. In this case, it's easier to deal with 77 and 21 than it is to 132 and 36, at least in my eye. So I'm going to use this one, right, this proportion. Okay, I'm going to kind of ignore this one up here. Okay, so I can take a 7 out of this. This becomes 11. Take a 7 out of that, it becomes 3. So we've got that reduced. 30 times 11 is 330. And then 3 times the quantity 11x plus 11. Don't forget that you're multiplying both parts by 3 there. Okay, so you've got to have parentheses. However, I'm not actually going to distribute that in because I recognize 3 goes into 330. So I'm going to start by, since we're multiplying by 3 there, I'm going to divide both sides by 3 and give me 110 is equal to 11x plus 11. Subtract 11, I get 99 is equal to 11x. Divide by 11, I get x is equal to 9. All right. So x would have to be 9. You can double check it. You get 99 plus 11 or 110 here. And then if you compared all 3 of your ratios, you should get that 11/3, right? 110 over 30, that would be 11/3. You cancel your zeros. And then 132, 36 there, you could also go ahead and, yep, you get the same thing there. All right. Very good. You take out a 4 there, you get 33 over 9. And then you take out a 3. 11 and 30. Okay, so they all reduce to 11/3, so x is 9. We did it correctly there. And we double check it. Okay, so the same thing here. Go ahead and look at it. We have big triangle and big triangle and big triangle here. Okay, so if I compare sides, I'm looking at, I think I'll go ahead and compare the 96 to the 36. 96 is to 36 as as 64 is to -4 plus 4x. Okay, and I'm going to go ahead and reduce. We're going to take a 12 out of this, so it's going to be 8 and 3. Okay, and then I could actually reduce this whole thing by 4, right? Do some good algebra, take out 16 there, and take a 4 out of this, becomes -1. Take a 4 out of this, we get plus x. Okay. All right, so we get 8/3 is to 16 over, or excuse me, 8 is 3 as 16 is to -1 plus x. Cross multiply, we get -8 plus 8x. And 3 times 16, we end up with, well, that's 48. Add 8 to both sides, we get 8x equals 56, and x equals 7. I'm not going to check that one. I know it works out, but you can plug them in and double check if you like there. All right, let's go ahead and talk about the other way this proves triangle similar, side angle side. So if an angle is congruent to an angle of a second triangle, then the lengths of the sides including these angles, or excuse me, and the lengths of the sides including these angles are proportional, then the two triangles are similar. So in other words, let's go ahead and look at that. We have A, B, and C, and D, E, and F. So let's say angle A is congruent to angle D. Okay? And then we know that the sides including that angle, that means the side on both sides, each side on either side of the angle. So let's say that that was a 2 and this was a 4. Okay? Actually, let's not use 4. Let's say that's 2 and this side's 1. All right? And this side is 3. That would mean this side would have to be 1.5. Right? So 2 is to 1 as 3 is to 1.5. All right? So in other words, AC is to DF as AB is to DE. All right? So we'd have our side angle side. Okay? Side angle side. All right, so the angle has to be in between, and they're the congruent angles. So determine if the triangles are similar. Explain if similar. Write a similarity statement. Okay, and so this first one here, first thing you need are angles that are congruent. And we've got them right there. Okay, so angle U is congruent to angle F, and let's see, 9 would have to be to 21, as 18 would have to be to 42. Okay, well I'm going to reduce again. That's 3 and that's 7. Take a 3 out of each of those. And take a 2 out of this, or excuse me, take a 9 out of that twice and 9 out of that 7 times. Oops, that does not work. Oops, I can't take a 9 out of that. I'm sorry. Take a 6 out of this 3 times. Take a 6 out of this 7 times. That works out. We get 3 7s equals 3 7s. So the sides are proportional. The angle in between are congruent. So by side angle side triangle, WUV is similar to triangle HFG. Okay? Congruent side angle and proportional side. So you've shown your work, and there you got it. All right, well, let's take another look at another one here. So I look at these two triangles. I recognize right away I have vertical angles. Therefore, angle MLV, actually let's go with MVL there, not MLV. MVL is congruent to angle TVU. Okay. And then looking at the sides, so 8 short side to short side, so 8 is 28. As 14 is to 49, let's make sure that works out there. I can take out of 8 and 28, I can take a 4, that becomes 2 and 7. 14 and 49, I can take a 7 twice and 7. 2 over 7 equals 2 over 7. Sides are proportional. We have an angle, so by side angle side, triangle MVL is similar to triangle TVU. And we've shown our work there. All right, there we go. Okay, I think that's it. Let's summarize what we have so far about proving triangles similar. So what are the 3 ways to prove triangles similar? Well, the first way is angle-angle. So that was a different lesson. The angle-angle says, okay, if 2 angles, I'm going to abbreviate a bit, on one triangle are congruent to 2 angles of another triangle. So picture-wise, we could say there, 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 and there. Then the 2 triangles are similar there. Okay. We also have the one of the ones we talked about today, side, 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 side. So we have 3 sides of one triangle are proportional to 3 sides of another triangle. All right, so let's say we have A, B, C, D, E, F. We can say, well, if AB is to DE as AC is to DF as CB is to FE. The last one, side angle side. All right, so if an angle in, oops, let's fix that there, one triangle is congruent to an angle of another triangle, and the included sides are proportional. All right, so once again, A, B, C. Actually, let's use different letters this time. Huh? All right, let's go with Q, R, S. There we go, getting crazy. Okay, and X, Y, and Z. All right, so let's say we have angle Q is congruent to angle X. And then we have QR is to XY as QS is to XZ. All right, those are the three ways. I think that's all I got now. Yep, good lucky.